Let's have trigonometric functions. You are given one function of an angle, and then you will give the other 5 trigonometric functions. So before we proceed to the examples, let's have the 6 trigonometric functions. First is we have sine theta, that is equal to y over r. Cosine theta, that is equal to x over r. Tangent theta, that is equal to y over x. And the 3 remaining trigonometric functions are the reciprocal of sine theta, cosine theta, and tangent theta. So let's have the reciprocal of sine theta. And that is cosecant theta, that is equal to r over y. For the reciprocal of cosine theta, we have secant theta, and that is equal to r over x. And for the reciprocal of our tangent theta, we have cotangent theta, and that is equal to x over y. So let's have an example. Example number 1. Let theta be an angle in standard position. Find the exact values of the other 5 trigonometric functions if theta lies in quadrant 4 and sine theta is equal to negative 5 over 13. So let's have the solution. Since sine theta is equal to negative 5 over 13 and theta is in quadrant 4, again in quadrant 4, the sign of our order pair is positive and negative. The sign of the x-coordinate is positive while the sign of the y-coordinate is negative. Sine theta is the value of y over r. Meaning, your y now is equal to negative 5. Negative 5 because in quadrant 4, your y-coordinate is negative. And r is 13. Positive 13. Again, r is always positive. And we are given y, we are given r, but we don't have the value of x. Meaning, before finding the other 5 trigonometric functions, you will be needing the value of your x. And to find that, we will be using the Pythagorean equation. So that is x squared plus y squared is equal to r squared. Since we're looking for this x, we need to derive a formula of x from this one to solve the value of this x. So we have now x is equal to square root of r squared minus y squared. So let's replace r and y. So we have now equal square root of, we replace r by 13, that's why we have 13 squared minus, we replace y by negative 5, so we have negative 5 squared. So let's simplify. So x is equal to square root of 13 squared, that is equal to 169, minus negative 5 squared, that is 25. So let's subtract 169 minus 25, and that is equal to square root of 144. When we simplify square root of 144, we have x is equal to positive 12 or x is equal to negative 12. Para makapili ka dyan sa dalawang yan, tingnan mo yung ang theta mo. Saan siya located? Since our theta is located in quadrant 4 and our x-coordinate, the sign should be positive. So meaning, kukunin mo itong positive value mo. So we have now x is equal to positive 12. Since you have now the value of your x, pwede na natin mahanap ang other 5 trigonometric functions. So let's have x is equal to 12, y is equal to negative 5, and r is equal to 13. So let's find now the other 5 trigonometric functions. We are given the value for sine theta, and that is equal to negative 5 over 13. So let's have the other 5. So let's find cosine theta is equal to x over r. Let's replace x by 12, and let's replace r by 13. So here it is, we have 12 over 13. That is the value for cosine theta. For the tangent theta, we have y over x. Replace this y by negative 5. Replace this x by 12. So we have now negative 5 over 12. Or you can rewrite it as negative 5 12th. So that is the final answer for tangent theta. For the cosecant theta, that is equal to r over y. Replace this r by 13 and this y by negative 5. So we have now 13 over negative 5, or you can rewrite it as negative 13 fifth. So that is the value for cosecant theta. For the secant theta, we have r over x. Replace this r by 13 and this x by 12. So you have 13 over 12, and that is the final answer for the second theta. For the cotangent theta, we have x over y. Replace this x by 12. Replace this y by negative 5. We have now 12 over negative 5, or you can rewrite it as negative 12 fifth. That is the value of cotangent theta. Let's have example number 2. Let theta be an angle in standard position. Find the exact values of other 5 trigonometric functions if theta lies in quadrant 1 and second theta is equal to square root of 5 over 2. For the solution, since we are given second theta is equal to square root of 5 over 2, and our theta is located in quadrant 1, again in quadrant 1, the signs are positive, positive. The x-coordinate is positive. The y-coordinate is positive. And second theta is the value of your r over x. Meaning, your r is equal to square root of 5 and your x is equal to 2. You have the value of your r and x, but you don't have the value of your y. So, to find the other 5 trigonometric functions, you need to find y. And to find that y, we will be using Pythagorean equation. You have x squared plus y squared is equal to r squared. And from this equation, we need to derive a formula for y. And that is, y is equal to square root of r squared minus x squared. Let's replace this r and x. So y now is equal to square root of, we replace r by square root of 5. That's why we have here square root of 5 squared. Copy the minus sign and then replace this x by 2. That's why we have 2 squared. Okay, this time let's simplify. So y now is equal to square root of 5. Square root of 5 squared, the answer is 5. Then minus 2 squared is equal to 4. And again, let's simplify. 5 minus 4, that is equal to 1. So we have now square root of 1. And to simplify the square root of 1, y now is equal to positive 1 or y is equal to negative 1. Para pumili sa dalawang yan, look at the location of your theta. Since your theta is located in quadrant 1 and your y-coordinate is positive, meaning ito ang pipiliin natin. So your y now is equal to positive y, 1. Since you have now the value of your y, which is 1, pwede na natin mahanap ang other 5 trigonometric functions. So your x is equal to 2, your y is equal to 1, and your r is equal to square root of 5. So hanapin natin ang other 5 trigonometric functions. So we are given second theta, which is equal to square root of 5 over 2. So let's start with sine theta, and that is equal to y over r. Let's replace y by 1 and let's replace r by square root of 5. So here it is. We have now 1 over square root of 5. Again, we have a radical expression in our denominator. So meaning we need to rationalize it. To rationalize the expression, you need to multiply both numerator and denominator by square root of 5. So, to solve that, 1 times square root of 5, you have square root of 5. Square root of 5 times square root of 5, that is square root of 25. And square root of 25 is equal to 5. Meaning, your sine theta now is square root of 5 over 5. For the cosine theta, that is equal to x over r. Replace x by 2 and replace r by square root of 5. So, here it is. So, you have 2 square root of 2 over square root of 5. Again, you have a radical expression in the denominator, meaning you need to rationalize it by multiplying square root of 5 both numerator and denominator. So, ayan na siya. So, let's simplify. 2 times square root of 5, we have 2 square root of 5. Square root of 5 times square root of 5, that is square root of 25. And square root of 25, that is equal to 5. That's why we have now 2 square root of 5 over 5 for the cosine theta. For tangent theta, that is the value of your y over x. For replace y by 1 and replace x by 2. And here it is. And that is the value of your tangent theta. For the cosecant theta, we have r over y. Replace r by square root of 5 and y by 1. So you have now square root of 5 over 1, or you can write it as square root of 5. So that is the final answer for the cosecant theta. For cotangent theta now, we have x over y. Replace x by 2 and replace y by 1. And we have now 2 over 1 or simply 2 for the cotangent theta. So that is the final answer.